Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Okay, today let me present to you the power formula in three-phase. We have already a power formula for single phase, and three phase is that is a single phase in 3 times. Okay, you multiply 3 the single phase, and that is 3 phase. And always keep in mind that in each phase it is electrically distance at 120 electrical degree. So for the three phase power, okay, power formula, okay, and for further discussion, okay, we have the general formula for a polyphase for power, which is P is equals to N times B phase times I phase. I am using the phase value here, and this is multiplied by the power factor cosine theta. This is the power factor angle. Now we just replace N here by an exact value of 3 because we are in 3 phase. So our formula becomes 3 times B phase times I phase and cosine theta. So we are connecting actually our coil for the generator or the load side into 2. We can connect that into a delta connection since we are in 3 phase. Delta connection implies 3 coils, and also Y connection instead of using mesh. So when you use Y connection, it just imply that you have 3 coils involved. So for your delta, okay, this is the figure or the circuit diagram. So each one here is BP, BP, and BP. By the way, this is in balanced circuit because there are also circuits that our phase voltages and line voltages are not balanced. So that is another topic. So this is the terminals, and this will be your I sub line, and the current that is flowing through the phase is your current phase or I sub P. You have also here I sub P. You'll notice that it converge here, and I sub P are added, and it gives you I sub L. So in the delta connected coil, whether it can be this is a representation for a generator or a load. Now if the current is going out, this representation is a load or a source. A source, not a load. Okay, so emphasize that. It supplies, so it is a source. It gives power. Now if the current is going in, that is a load. Okay, so therefore we have again here for our the line voltage. We took the voltage at the terminal, that will be our line voltage, and we easily inspect the circuit. We can find out that BP, the phase voltage here, is equal to the line voltage, and the current, okay, the current I sub L is this is actually twice of your current that goes through the phase voltage or the phase current. So this is twice IP at an angle sine 180 degree. Since that we are dealing with 3 phase, we divide this by 3, and if you are to get your calculator and press the value of this, multiply to this one, that will give you a value of actually the square root of 3 IP. So therefore, the line current in your delta connection is equals to the square root of the phase current. That's for delta. And for your Y connection, okay, it is like this one. Okay, so that is okay. So you see here again BP, BP, B sub P for the phase voltage balance, and the current that goes through here is IP, and the current that is in this terminal is I sub L, okay, the line current, and the voltage here, which will be B sub L. So also with here B sub L also. Every terminal voltage is named as VL or V line, okay, and this one is the B phase. So by observation, you will conclude that the phase current is equal to the line current, okay, and the voltage here, if you will notice, if you will take these two terminals, this one will be hanging, so you'll add the two voltages here. So actually B sub L in this Y connected coil, which represents our source or supply, VL is actually, you'll notice that is twice the phase voltage sine 180 degree divided by 3. And actually, if you are going to press your calculator, sine 180 degree divided by 3, which is 60 degree, times 2, you will have square root of 3 B sub P. So VL is equals to square root of 3 times B sub P for a Y connected system. Now, what is the implication of this one here in the formula for the 3-phase? So we use here the phase voltages and the currents. Now, if you're going to get the value of your power in terms of your voltage line and current line, okay, so BP here, or B sub P, is equals to VL, okay, and let us first consider a delta connected circuit. So your B square root of 3 BL for BP, and for your IL, that is square root of IP. So we are going to conduct an algebraic manipulation of this one. So your phase current is the line current divided by the square root of 3. So if you are going to substitute this one here, that will become I sub L over square root of 3, okay, cosine theta. And 3 square root of 3, okay, 3 square root of 3. Okay, so I will use one value, which is square root of 3 over square root of 3, to be able for us to remove the radical sign in the denominator, and we copy B sub L times I sub L cosine theta. So therefore, when you multiply the denominator, this will be 3 squared square root, so that is 3. So that will be 3 over 3. So that will be cancelled out. So this are cancelled out. What remains is the square root of 3. So B sub L times IL cosine theta. Okay, so the value for getting the real power or P using the line current in your delta connection is this one. Now, if you are going to consider also Y connection, the same result, it will give you the same result because the B sub L here is the one that will give you the result of B sub P equals B sub L over square root of 3. And when you substitute it here, the same thing, it will give us the same result. It's the same thing, okay? So this is your equation for P using phase currents and phase voltage, and this one line current and line voltage. Now for your Q, okay, your Q is actually again 3 times B sub P times I sub P. Since our Q is on the opposite side, no? So opposite side of your angle theta, so we use sine theta. So therefore, same thing, if you are going to use here the line currents or the voltage current, you will have square root of 3 again, B sub L, I sub L, and then sine theta. Okay. Okay, and for the apparent power, okay, we just have 3 times B phase times I phase. Okay, for your current and voltage values in line, the line currents or voltage, again, that is square root of 3 BL times IL. So again, our 3-phase is represented by a right triangle, okay, in which this is your P, here is your Q, and your hypotenuse is the S, and this is your theta. So that's why the cosine, the power factor of this system, which is cosine theta, will be your real power. And for the reactive power, you have here Q, okay, and Q is sine theta. And for the apparent power, that will be the hypotenuse. So these are the formula that you can use in solving for the 3 power in alternating current, specifically 3-phase. Okay, and also always remember, okay, take note, okay, that we can also use the idea that your power factor angle, which is theta, okay, is the angle, this is the angle, okay, I am writing it, the angle between, okay, between the phase voltage BP and the phase current. So from this idea, we can solve problems, okay, involving the phase and phase voltage and phase current, and we can get the 3 types of power in 3-phase power system. So this is all for the 3-phase power formula. Thank you so much for watching this video.